Okay, problem number 14 from, I think it's page 128, this is section 4.6. Two skaters, an 82-kilogram man and a 48-kilogram woman, are standing on ice. Neglect any friction between the skate blades and the ice. The woman pushes on the man with a force of 45 newtons due east. Determine the acceleration's magnitude and direction of the man and the woman. So I'm going to draw a man here. There's my man. Oh, so he is on, the woman pushes on the man with a force of 45 newtons due east. So I'm going to call this east, and this will be west. And so let me draw the guy farther to the right here. So he's going to be here, hands out, and he's on some skates here. Those are skates. Okay. So that's our guy. And the woman, let me use purple here. It's here. She's going to press on his hands. She has skates. There's her womanly hair coming from her eyes. Okay. She's 48 kilograms. And she's going to press on him with a force of 45 newtons. And we know that for every action there's an equal and opposite reaction. So if she's pressing on him, he then is applying a force back equal to 45 newtons. So if we just looked at what's happening to her, or let's do him first. If we would just look at what's happening to him, if he was just like a block, and we looked at the forces coming in on him, we'd see that 45 newtons is acting on him. And if we looked at her, she's just a block, we'd see that 45 newtons is acting on her in that direction. His force is going to push him east, her force is going to push her west. And we are wanting to know the accelerations. Alright, so if we have the masses, the mass of the man was 82 kilograms. And we have the force that's acting on him, we said that's 45 newtons. That's in the east direction. We can find his acceleration with the equation force equals mass times acceleration. Rearrange that to where acceleration equals force divided by mass. And the same goes for her. We can simply say, okay, we know her mass is 48 kilograms. We know that her the force acting on her is 45 newtons, and it's going to be in the opposite direction of what force she applies to the man. So if her force to the man was east, the force acting on her would be in the west. And then we have acceleration, and that's what we're trying to find. And we're going to do the same thing. We're going to use this equation right here. Acceleration equals force divided by mass. So now all it becomes, let me put newtons there. All it becomes is just plug in the numbers and use your calculator to check out an answer. So acceleration equals 45 divided by 48 over here. The acceleration is going to be 82 divided by, oh wait, I flip-flopped it. It's going to be 45 divided by 82. And let's get out the calculator. 45 divided by 48 is going to give us an acceleration of 0.9375. We have, I think the lowest amount is 2 sig figs. So this rounding to 2 sig figs would be 0.94. 0.94 meters per second squared. Put 0 up front there. And his acceleration would be 45 divided by 82. That gives us 0.548, and we want to round that up to 2 sig figs, so it's 0.55 meters per second squared. Now, does this make sense? Does our answer make sense? Hers is 0.94. That's a reasonable acceleration. It's not, way off the scales that we're used to. And his is 0.55. Now his acceleration is less. Does that make sense? Yes, he has a greater mass than what she has, right? So the forces are the same. That's the same as the 45 over here. It's just in opposite directions. So it does make sense that his acceleration is going to be less because it's a heavier object is going to move slower if a force is applied to it than what a lighter object would. It's easier to throw a baseball than a weight that you'd lift in the gym. So yeah, the answer makes sense.